At Fermilab, we study nature at its most fundamental, drilling down to the smallest scales of matter using some of the largest and most advanced machines in the world. Accelerators, powerful microscopes, send particles barreling at near light speed into other matter, creating subatomic scraps. Detectors zoom in on those fleeting pieces, making the invisible perceptible. And sophisticated computers sweep through all of it, crushing mountains of information into gems of data. We also use our cutting-edge technology to explore the mysteries of dark matter and the quantum realm. Thousands of scientists from around the world partner with Fermilab to explore how the universe works, expanding humanity's understanding of matter, energy, space, and time. Fermilab is solving the mysteries of the universe.
Hi, everybody, and welcome to Fermilab's Open House. I'm Lori Hasseltine. I am the Education Program Associate here at Fermilab in the Office of Education and Public Engagement, and I will be your moderator today. One of the things I love about Fermilab is the diversity of talent and the backgrounds of people that work here. That's what makes our science so good, because we have a better perspective when we have the diversity. So what we're going to do here is I'm going to start by asking people to introduce themselves and then give us a little bit of an idea of what your job is at Fermilab. And then after that, we'll also go into the path that you took to get to where you are now. Our panelists are Aisha Ibrahim, Luciano Elementi, Akshay Murphy, and Samantha Sword-Feldberg. So let's see. Aisha, do you want to start?
Sure. I had some time this morning. I threw together a couple slides. Could I share them?
Sure.
All right. Okay. So just a little bit about me. I'm the daughter of immigrants from the Philippines. I'm a firstborn American that grew up in Texas, in Houston, actually. And so I'm a product of pop culture of the 80s. I'm not ashamed to admit it. So my fascination in STEM actually started, listening to MacGyver and Star Trek. Star Trek, you guys probably know about. MacGyver is a little bit not so well known. He worked for a government company, nonprofit organization, but somehow he always got into these weird situations where he had to use a unique problem-solving ability to get out of defuse bombs or get out of traps and that sort of thing. But coupled with my own love of science and math and just being inspired by what I saw in pop culture, it really drove me to become an engineer and wanting to build things and solve problems. In 1996, I graduated from high school and got admitted into Illinois Institute of Technology. They recently renamed themselves as Illinois Tech on a scholarship. I graduated in 99 and I went through a few different companies, but in 2002, that's when I landed in Fermilab. Several things happened between college and 2002 that really honed in on what I wanted in my work environment. I wanted something that really allowed me to be curious in my work, be allowed to design. I wanted to work more in teams, but still have the flexibility of my own independent, drive in what I'm making. I'm also a mother of 4 kids. This picture in the corner here was taken right before we all went into lockdown and COVID. It was a nice day out in the city. So I graduated from Illinois Institute of Technology as an electrical engineer. And at Fermilab, the scope of what I need to work on really has to do with the beam transport, right? We generate, the beam starts here and it traverses all the way around on all these lines into various, and eventually dumps themselves into different experiments. And my group basically tracks what the beam does as it goes through all of these beam transport lines and around the actual accelerator. What do I mean by what does the beam do? Well, you know, how much beam there is, where it is in the beam pipe, what does it look like? So our group handles a whole bunch of instruments. It's called beam instrumentation, that give you basically these fundamental measurements. If you think of an analogy to a doctor's office, the systems we make would be equivalent to a thermometer or an X-ray machine, a CAT scan, things that the scientists or the doctors, in my analogy, would need to have measurements to basically make their diagnosis. I don't get to work on all of these systems here. I primarily focused on the two in the upper left corner, and those give you the beam current or the beam intensity, how many particles are actually at any point, at any time, position in time or location as the beam travels around the accelerator and transport lines. However, even though I only get to work on one of these systems, everyone in our group really has to work on everything from the pickup, which is shown on the left, all the various pickups that we have, to the actual electronics. So I've been at Fermilab now for close to 20 years, and I've had a chance to help design, work with transformers and magnets and mechanical support group to design the pickups. And then I've had a chance to lay out boards and then program them, as well as design any of the analog circuit that needs to condition the signals.
Thank you so much, Aisha. That was wonderful. Let's see, Akshay, would you like to go next?
Sure, I'd be happy to. So my name is Akshay Murphy, thank you, Lori, for introducing me. So I've actually only been here for 1 full year. I'm currently a research associate in the division of superconducting quantum computing. So what I do is, my background is actually in the area of material science. So I got my PhD at Northwestern University in that area. And after moving to Fermilab, what I primarily work on is a lot of analysis of our superconducting quantum computing systems in order to look at how do we improve the properties further. And a lot of this is done through various materials characterization techniques. So really trying to identify what it is what it is that's limiting the performance of these systems through various techniques such as electron microscopy and other methods. And I'm happy to talk more about that later. But that's just a little bit about myself.
Thank you very much. And Samantha, would you like to go next?
Sure. I also put some slides together. Can you see those?
Yes.
Great. So my name is Samantha Sword-Feldberg. I'm currently a PhD candidate, which means I'm a grad student working here at the lab. A little bit about me. I was born and bred in New Mexico, and I love spicy food. So I like to eat things like smothered burritos that you see here. But I also love to do things like playing volleyball, going swimming, camping, hiking. I like to cook and bake. And I also like to play video games. I also have a dog and 2 cats who are super spoiled. But I like to do a lot of things other than just physics. A little bit about me. So I graduated with my bachelor's in science in physics and astronomy from Northern Arizona University in 2016. And in the fall of that same year, I started grad school at New Mexico State University. 3 years later, I earned my master's also from NMSU, which was a non-thesis master's in particle physics. And in May of this year, actually, I'll graduate with my PhD in experimental particle physics from NMSU. So you're probably wondering what I actually do. So as I said, I'm a PhD candidate. That means I've passed all of my graduate classes, and I've been working on research that's going to go into my thesis. Specifically, I work on a neutrino experiment here at Fermilab known as microboon. So we basically receive beam from Fermilab, And we go ahead and we analyze that beam in order to find neutrino events. So this is actually a sample of an event in our detector from a program called Venue. It's actually really nifty. I would encourage all of you to download it. You can look on your phone. But in this event, there's actually a neutrino event. And this is something that you can easily train a physicist to look for. But my job is basically to tell a computer how to find these events. The other thing to keep in mind is, while this is a single event, there's tons of data, so much data. And only 1 in 600 spills that we get from the BMB will actually produce a neutrino event. So finding these neutrinos is like trying to find the needle in a haystack that's in a tornado. So the other cool thing about my job is, in addition to doing research, I also get to travel all over the world and talk about the science that we do on Microboon. So this is actually a picture of me in Italy taken over Zoom, presenting on behalf of Microboon. How did I get here? It's a little bit of a windy path. So when I was in high school, I actually really wanted to be a band director. But I had a really great high school teacher who basically got me to love astronomy and math again, which is something I had lost kind of as I had grown up. I even went on later that same year to build an astronomy program for my Girl Scout Gold Award. And this is an example of a telescope that I had been working with to develop. When I went to college, I was encouraged to take astronomy and physics, and I later found out that I really loved my physics classes. They were super exciting. I got to do fun demos like this one here, and I just really loved talking about it and doing it. And so when I graduated in 2016, I knew I was going to go to grad school to get my degree in particle physics. And this is actually a picture of me in my office at Fermilab prior to COVID taking place. That's all I have to say about myself.
Thank you, Samantha. And Luciano, would you like to go next?
Sure. So I have some slide that I kind of recycled them. Let me see. First I need to, share screen. Is that correct?
Yes.
Okay, so I was born long time ago in Genova, Italy, and but my connection are in the Piedmont region. Beautiful place. In the Piedmont meaning the foot of the mountain, and Genova is capital of Liguria, and it's one of the most beautiful cities in the world. I have 3 kids, my family. Big harbor, and of course the house of Christopher Columbus and for Niccolò Paganini, which is right here, so that we placed it on the map. And this is the Piedmont region at the Valley. Graduated in high school, military service, honor in MS and Master Science, Electrical Engineering. Moving Houston. So I applied for a job at Fermilab as an engineer, electrical engineer. And I ended up working, started working for the LHC, the quadrupole, that now are working at CERN. We built several quadrupole. I worked on many machines. My occupation here has been as a sort of a system engineer for machine tooling. And for example, this is a picture of me like when I still had the air and the cable machine. We build magnet. My division is my department is the department of magnet. And so, for example, this is a big magnet that it was called Class 12. Jefferson Lab. We build magnets for other laboratory very often, so when they are special, like in this case. And our group, I have a small group, and we deal with machine like wrapping machine and baking the magnet, wrapping, keeping the tension, whatever. We build myself and my small group especially is dedicated to building specialty magnets. Like in this case, is a kicker magnet. We do control system like high pressure rings, all the controls for this cavity. I can explain more if there is any questions. Currently, we are dealing with a R&D project, basically, which is called QCD. It's increasing the charging of the magnet to hopefully decrease the number of quenches. Cabling machine, and here is another magnet, which again I'm involved in is an AC dipole. This is for an experiment which is called mu2e, and that's it.
Thank you, Luciano. If anybody has any questions, please put them in chat and we will get to them. So my next question is what, and this is for each of you, I don't care who wants to answer first, but what kind of advice would you give to somebody just starting out in this field, in your field?
I can go first.
Okay.
So physics is really interesting, but it's also, the field is a little bit deceiving. I think many a times when we're younger, we kind of believe that science is just sitting in a lab doing something, you get a result out, and then you're like, look at my result. But there's a lot more that goes into it, especially when you're working on experiments that are like this big. So one thing to keep in mind is that even though you're a scientist, it really matters to have really good writing skills. Being able to communicate your science is something that's really important nowadays, especially since, you know, we're reaching all the corners of the world. Another thing that is really coming online in the last couple of years is programming as well as data analysis. Not everyone does data analysis, but pretty much every physicist I know does some sort of programming, whether that's C++, Python, MATLAB, you name it. And so developing those skills rather early is very important. So,
Akshay, do you want to chime in and give your thoughts?
Yeah, I mean, I think Samantha pointed out some very good aspects. One thing for Lori, before I start, so in terms of the audience, what are we looking at primarily? Do we have?
You know, I am not really sure. I think it's kind of across the board. We do have some teachers who have been registering for some of these events as well. So.
Yeah. Okay. That sounds good. Well, welcome. It's good to have a diverse. Oh, awesome! An 8th grade class.
Yeah.
Well, that's great. I mean, I think the biggest thing is just to like be open to the possibilities in terms of physics. So for me, I mean, I think what I'll say is that from my perspective, I had never foreseen myself going into this area. So I liked a lot of chemistry and was actually worked in a semiconductor industry for a little bit of time. And then it was just one of those opportunities where I never knew that material science would be something that would be critical in this new area of quantum computing. And it was only through various connections and discussing with other people that it even became clear that this was the sort of skill set that they're looking for. So really just, I would say, find what you're interested in terms of whether it's in a different area or anything like that, and then see how the skills that you have might be able to be something that can be useful in that field. And it's sort of, that's what certainly has worked for me in the past, and something that will continue to be in the future. So, I mean, I think it's nice to see a nice group of people across various grades. But yeah, I mean, if there's more specific questions, I can absolutely take that.
Sure. Aisha, do you want to chime in?
Yeah, sure. So just adding to what Samantha and Akshay has said, you know, as an engineer, you have, you know, there's so many variations of what you could do as an engineer, even as an electrical engineer. And what I've learned over the year is what you learn in school, high school, college, grad school, you have to think of those just as tools, right? When you think of your career, you have to aspire a little bit more and think about how you want to apply those tools. And sometimes your secondary interests outside of school actually will bring you into a career that you absolutely love. For example, I have a friend, they love music. And they actually, while through college, they kept up with their music as they did their engineering degree. And they ended up realizing that actually merges together into acoustic engineering. Now he realizes there's a program that deals with sonar out in California. So now he's working on sonar studies that has to do with acoustic and / electrical engineering aspects, out in submarines and working with marine biologists. So that's your council will never find this for you. This is something you have to, keep yourself talking and networking with people and open to aspects that may not be the conventional job, but if you merge all your passions together, you might find a career that you absolutely love and wouldn't mind putting 8 hours a day in.
And Michael says music is a fantastic base knowledge for physics. So I would say that that's probably very true. I think music has a mathematical base to it anyway, and that's a lot of what you do. Luciano, how about you? Is there anything that you want to add?
Yeah, just adding, because I do go along with my colleagues on every aspect indeed. And so just adding is two things. One is to keep being curious, keep being inquisitive. I think it's an age where people are starting to ask why, and the more you do, the more you get to a point where your parents or your teacher cannot answer anymore. And so there is library, there is us, there is resources out, and you can get to a point where you need to break the path. That would be the best. That's fantastic. And so keep being inquisitive, and hand to hand with inquisitive is don't be scared, don't be afraid. There is sometime it happened that there is a thing like quantum computing. Oh my God, I'm never going to understand that. But there is really nothing so special. It's just vector and spaces and some complex numbers, and you eventually get it. And so it's cool. So don't be scared and keep being inquisitive. That's my suggestion.
What is your favorite part of your job? And I'll ask each of you these. And what's the hardest part of your job? Luciano, do you want to start?
Yeah, sure. That's easy. My favorite is when things work out. I like, you see, I do these tools and I put together machines, and when they, for some reason, it's a small pleasure to see them doing what you expect them to do, because it's actually, I can say the struggle to get to that point is actually in the aftermath is good, but during the struggle is a struggle. But then when you get it going, it's a pleasure. So I like both the struggle, but not during the struggle, and the aftermath. Yeah, sure. When the machine do operate, and the hardest part is the bureaucracy. That's probably any sizable company. There is quite too much of it in the recent years. So that's the hardest part for me, is doing the bureaucratic part, the managerial part, and so on. That's the hardest indeed. It's boring and hard, and it's the part I like the least. And there is some of it.
Yeah. Akshay, how about you?
I mean, I think Luciano nailed it perfectly. I mean, I think for me, at least, the hardest part is my favorite part, right? It's like the part in terms of so getting to the point where you have a really nice research finding is great, and I think that's phenomenal. But for me, and I think for a lot of physicists and really scientists and researchers out there, it's the process to get to there that's so enjoyable, but simultaneously so frustrating and angering. So it could be something like your experiment doesn't work, and then you have to think about how you want to modify that, or how you want to try again next time. Where that constant struggle, that's why we're here. That's why we continue to do this. It's enjoyable. But if anyone were to say it's not frustrating, if it's not hard, then I think we're lying. So I think it's both. So just in general terms, it's it's that aspect of it for sure.
Aisha, anything you want to add?
Yeah, I agree. I'm a problem solver. I like puzzles and stuff. So for me, when something breaks, that's the most exciting time. You get to collaborate with other groups, dig into what the latest technology is in industry, and then try to design something new. So that's my favorite part of the job. And then conversely, I think when we actually commission it or install it in, it's sort of like, right before you step on stage for an audition, you have all those butterflies. Did I forget anything? Are things going to work? And those are that anxiety is probably something unavoidable, but it's probably not the part I enjoy the most.
And Samantha, how about you?
A lot of individuals have addressed things that I would have said, so I'm going to say something different. I personally, my favorite part of my job is both sharing in the successes and the failures of your experiment together with your friends. Science is super collaborative, especially when you're working at somewhere like Fermilab or CERN. There's literally thousands of scientists. And every day is a joy when I get to work with my friends. I learn something new every single day because I have friends from all over the world, and I don't know about a lot of things about the world. But it's always so much fun when you finally get to release like your signature result and you're all there together sharing in that. I think for me, the hardest part of my job, besides things not working, is tackling yourself every day. So I think a lot of times whenever we see failure as human beings, we immediately think that like something's wrong with us, or that we're a failure ourselves for something not working. But the hardest part of that is it's simply not true. You have the power to overcome yourself every single day, and to realize that like this is just an opportunity for you to grow and to learn more, and to still contribute to the world. Yeah.
What would you say is your greatest accomplishment so far in your job?
I can go first again.
Yeah, go ahead.
So I think my biggest accomplishment to date is I just recently finished up my analysis, and we're in the process of getting ready for publication. And again, that's just a really amazing feeling to know that all of this hard work has finally paid off, and that you get to share it with the world. There's something special about knowing that you've contributed to the knowledge of the human race. It's an interesting feeling, and there's nothing like it.
Akshay, how about you? What's your greatest accomplishment?
Yeah, so I've been here for a year, so it's not too much, but it's a similar thing, right? I think so far we've had a couple papers that have publications that have been available on the internet now. And I think what's so nice about it is not just the feeling of adding to that base, but also doing it in like a collaborative setting. So in the division that I work in, the superconducting quantum computing area, it's a collaboration between industry partners, between other universities, as well as national labs. And it's really nice to be able to complete a study that requires all of those groups in order to come together and learn something on how we can improve the quantum computing platform in the coming years. So I think my greatest achievement has been a publication that was recently available online.
Yeah, that's an exciting field that we're just starting to get into. So it'll be interesting to see what happens in the future with that. Luciano, how about you? What has been your biggest accomplishment so far?
So personally, we recommissioned an old welding machine, and it was intense. It's a welding machine. It was a TIG welding, so it's complicated to start with. It was built in the 80s. We had a very limited budget. We needed to make 2 magnets, so very limited number of product, and it was incredibly complex. So all the torches needed to start at the same time. We had a lot of hoops to go through and a lot of things. So, but when this thing was working, it was beautiful. Just seeing the light coming from the welding, it was just beautiful. I mean, I was really pleased. And but that's a personal accomplishment. Probably from a lab point of view, was kind of a more mundane. We've been recognized, for example, for the high pressure rings, which is just basically a robot that moves this cavity up and down and keeps the water pressure. For us, was more mundane, but it's actually one of the best machines in the world that we made. Other accomplishment was this big magnet, which I show in the slide. All the automation to make it. Yeah, sure, it was recognized, but after all, it was, we could see the end of it before starting. So from a personal point of view, it was much satisfying seeing the torch going. That's because it was more of a puzzle, more of a struggle. That's it.
Aisha, I think you still need to weigh in on this.
Yeah.
What's your biggest accomplishment?
Yeah, so I think I can think of 2. In one is that, with beam instrumentations goes into every experiment, right? Everybody needs it because that's the basis for all the measurements. So for me, it's just been great to participate in all the machines and almost all the experiments that have been at Fermilab. It's just, that's the reason why I've been here for 20 years, I think. But out of all of those, I think it was in the early days of the Tevatron Run 2. Before Run 2, you were focused on getting the Tevatron up and running, right? And it was running, but it wasn't to what to the performance that we needed to. We were way below our baseline performance. And that first year of Run 2, we really collaborate. We brought in resources from over the lab and started to tune up and optimize all our systems, and we were able to get it down from, for example, for the intensity monitors, from 5% error down to 0.5%, and that was really amazing to see. Just the drive the accelerator division had to do that, and all of a sudden we were just lining up with that baseline, and we had a huge celebration in NAD to do that. Made the DOE happy, but I think that was the best couple of years here. You kind of see the camaraderie, and you have a big success after that, that stems all the way up to the DOE. Yeah.
And Department of Energy, when you please them, that's a very big accomplishment. So
that was a great group effort. It was fun.
So there is a question from Michael. He says, for those in 8th and 10th grade watching, what advice do you have for those entering the next stage of their academic career?
I can say something. From negative experience, actually, I can give you the whole story anyway. My advice is, do not overlook classes that you may not be interested in. Do not say, well, I'm not really interested in. I'll skip it, or I'll take it lightly. I did skip. University, you can choose the classes you're following to a degree, and I didn't do compiler, and because I thought I'll never build a compiler, and I'm not that interested. But the thing that I would have learned by putting my mind into how our compiler works, it probably would have been really helpful in the future. So do not overlook classes just because, that's my advice.
Does anyone else want to pipe in?
Yeah, I have something to add. One thing that helped me in high school was sort of plan for college. That sort of forced me to take probably more advanced placement classes than, anyone would advise me to. But I was able to come in with 33 college credits just by taking those AP classes in high school, and I saved my parents a lot of money. I graduated in 3 years. I could have stayed another 4th year and just taken the time to, learn about other things outside, but I had already completed my degree at that point, but I could have taken the time to search other fields, right? So you have that 4th year to sort of discover yourself if you have the, financial availability to go the whole 4 years. Nowadays, a lot of the schools have not only advanced placement classes, but dual college credit classes. You can take classes in summer, so you have the prerequisites for some of these things. But you can't do that if you don't think about, what you want, how you want to plan for college. I think taking that into account early is probably the only way to do it.
Okay. Just as a note, this session is being recorded for those who are asking about a live transcription. So it is being recorded. Samantha or Akshay, do you want to add anything else?
So I can add something. I would say to the 8th graders in particular, when I was in 8th grade, I was taking advanced algebra at the time. And unfortunately, I was not able to keep up with the class. And it got to a point where I eventually had to drop the class because I couldn't keep up. Where my teacher eventually said, "You'll never be able to become a scientist because you've dropped this class." So that is really what killed my love for science, was that particular instance in time. However, I'm sitting in front of you here. I'm, several weeks away from getting my PhD. I took calculus. I took, all of those classes. I didn't even take physics in high school. And here I am, a physicist. So just because something happens doesn't mean that your path is totally defined. Also, when I was in 8th grade, I thought I knew everything, which I'm sure many 8th graders think too. But your life will change a lot, and the path you take isn't always linear. So don't be discouraged if something like that happens, but also recognize that you can still make it if you work hard. I personally did take AP classes in high school as well as dual credit college classes. I think dual credit was more useful for me because it allowed me to be able to get a lot of the classes that you're going to take no matter what, like English, beginning math, beginning chemistry, things like that. Everyone's going to have to take that class no matter what. And college is very expensive. So just keep that in mind if you're in 10th grade right now. But also, if you don't get to take those classes now, don't worry. You'll be fine. You will make it because somebody else has made it. So,
Akshay, anything you want to add?
I think Samantha summed up so well, but basically, yeah, I think never be discouraged. There's nothing that happens to you in middle school, in high school, even in college that would prevent you from becoming a scientist as long as you work hard enough. And I would say, in terms of more concrete advice, just take a look when you're in 10th grade or so, in the upper levels of high school. Just take a look into what careers are open, what things you're interested in, and as opposed to defining oh, I need to do this, I need to do this. Just learn more, learn as much as you can. Just be inquisitive, going back to the previous question. And I think a lot of these things will take care of themselves when you get to college, and you'll find out what you're most interested in. The career for you will likely be there. So that's basically my advice.
And everyone here at Fermilab comes to the job using different skills, education, and experience. And then you can always build on those as you progress in your career. So let's see, what is your biggest disappointment in your careers so far? Akshay, since you're here, why don't you take that one?
Oh, biggest disappointment. I mean, that's a tough one, right? Because I mean, right now I've been here for a year, like I mentioned. I'm pretty thrilled to be here. I think biggest disappointment might be, so after I completed my PhD, I was working at a different firm, and I thought that this was great for me, and like great opportunity, something that finally, after doing what, 17, 18, or yeah, I mean, like almost 20 years of schooling, it's like now I have a defined career, and it really wasn't what I thought it would be. And in terms of enjoyment that I got from work, in terms of having that level of intellectual curiosity, and I sort of felt like a disappointment, right? It's like I've worked all this way up, and then this is my career. But I think the key there is just, well, I mean, I think a lot of people mentioned this, is just use that as a positive. Now, more than anything, I've learned that that's not the type of thing I'm looking for, and that's when this opportunity at Fermilab really opened up as something that was much more in terms of having a lot of say, or yeah, having much more freedom, working in an area that I find very fascinating. And I'm here now, but I mean, I don't know if that's really answered the question, but I think the disappointment in life will, as long as you're open to it, will lead to something much more fulfilling. Is at least
sometimes there's a reason that things happen, and it can steer you. If you have a disappointment, it can steer you in the direction you need to go, is kind of what I'm hearing from what you said.
Yeah, I mean, exactly. So just like learn from your disappointments, and I think yeah, that's all I can add.
Yeah. Does anyone else want to chime in on this one?
Yeah, I have something I can add. It's sort of similar to what Akshay was saying. You know, once you get into your career, there's a little bit of a trade-off with being a jack of all trades and then becoming a subject matter expert, right? And as an engineer, you kind of want to do everything, build everything, program everything, but your job will sort of hone you in to one hole or another. While you probably love the hole you get in, there's always a disappointment that, oh, look what that other guy gets to do. And I think that goes for probably most fields in STEM. But as long as you like your hole, you can still appreciate what you see outside.
So go for what you love.
Yep.
Samantha, do you want to add anything?
Yeah. So from a younger me perspective, I would say that my biggest disappointment was whenever I would do badly in school. I think as many physicists, we care a lot about our academics and a lot about our grades. And I can remember like the disappointment you would have if you didn't do well on a test or something like that. And it was just always really frustrating. And it changes a lot once you get to actual research. Your disappointment is you've worked on something potentially for 3 years and then it gets cut, you know, or the funding's just not there anymore, or you find out that this thing you thought would work didn't work. And so it's similar that it's like, oh, I've reached this block. And so, you know, it's one of those things where like you should take some time to grieve, because it is a hard thing to realize, but you should also afterwards come out of it renewed with new energy and new, you know, knowledge to know how to move forward. Because the sun will always rise and neutrinos will always be there. And it's going to be okay. So.
Luciano, you've been here the longest of the panel members.
I'm afraid so. 21 years and some. Yeah, so I totally second Aisha. Yeah, it's there is a trade-off between being a generalist and a subject matter expert. So the disappointment is not being able to know everything about everything, and you get older and you feel, oh my God, there is so much that I cannot simply do because I'm getting older. And so in my position, I'm mostly a generalist, so I I know a little bit of a lot of stuff, but still some stuff I don't know much, and I wish I could. And so, yeah, but on the other side, you learn about yourself. You still learn a lot. So it's not really a disappointment, except if you see it that way. Like, you can say, well, I'm disappointed I didn't win the Nobel Prize, but really, it was not in my card to start with. So every disappointment, in a way, the disappointment may be with myself, but really I learned about myself. So it's not, it's again, a disappointment is a trade-off. It's a learning experience. I wouldn't say it's a, yeah, that's what I have to say about disappointment at work. I don't have many.
Okay. Are there any questions from the audience? I don't see anything in the chat yet, so. Okay. I do have a message. Thank you so much. We appreciate your messages about productive struggle. I do want to say before we end that we have a lot of other virtual programs on our Fermilab website. There's a lot of information in general on the Fermilab website. And also, I know Luciano and Aisha have both done interviews with the kids, and those are a lot of fun. And we'll also show you how much it really takes to run a lab like Fermilab, because we have people from all different occupations that signed up for those interviews. So please check those out. And we also have information on Twitter, on Facebook. So we're on all the social medias as well. So please check everything out. And thank you so much for coming. And thank you, Luciano and Akshay, Aisha, and Samantha for sharing your knowledge with us today.
Thank you.
Thank you.
Thank you.
Thank you guys for hosting.